So everybody has this note guide in front of them, right? What's the first word right there we're going to define? What does it say there? Relation. Before we define it, look what I have on the board. I have a picture, a cartoon picture of a thug. A thug from Pomona. And veteran students will recognize this thug, because I replay this every quarter. The story of a Pomona thug who had the audacity, who had the gall to actually steal an old lady's purse. Can you remember this thug?
Yeah, like 5 times.
Whoa. Moral of the story? Ask my class the first time. Sorry. Look at what this thug did. This guy is, we got to get this guy in jail, and we're going to get this guy in jail before the day is out. Hopefully some of you will, who are going to get the free assignment pass. So some of you didn't get the free assignment pass last time. By the way, Nava got the closest because it involved imaginary numbers. Those 3 assignment passes from that one problem, there was actually no solution because the radical was a negative. And so I just wanted you to struggle with that and try to figure that on your own. Right, but I wanted the number, and there was no number, so no one gets it. So it's kind of like a trick question. Are you mad at me, Ramirez? It's okay, I'll make it up to you. Watch this. After stealing an old lady's purse, a thug ran away from a cop. So this happened at the Chase Bank on Gary, and I want to say 2nd Street is where that bank is.
Yeah.
This thug went up to an old lady after she's done with the ATM, and she took her purse, or he took the lady's purse, and he started running away at a speed of, look at the speed, 4 feet per second. Really? 4 feet in a second? Let's see. 1, 2, 3, 4. Yeah. I mean, the guy's overweight. Look at the thug.
Bob, looks like a rock.
Well, his legs are small, so that's why it's 4 feet per second.
Someone's good lifting.
Yeah. So watch this. Check this out. I'm going to allow, so right now you're just listening, you're not writing a thing down. Right, Puente? Phone's away. I'm going to allow what I call my horizontal axis. Horizontal means left and right. This horizontal axis, I'm going to allow it to be seconds. So this means 1 second, 2 seconds, 3, and so on. I'm going to allow the vertical axis, that's up and down, the vertical axis to represent feet. Okay? This thug's running away. Shame on him. We're going to get a cop involved right now who's going to start chasing after him. But right now he's running at a rate of 4 feet per second. Okay? 4 feet per second. So at 0 seconds, he hasn't started running yet. He grabbed the old lady's purse. 1 1,000, 2 1,000. So at the first second, he's 4 feet away. Okay? So look at it. 1 second, 4 feet. 2 seconds, how many feet? 8, huh? Again, you guys just paid attention. 2 feet, or 2 seconds, 8 feet away. And so on and so on. Okay, that's the thug. What we've just graphed is a thug running away from the old lady with her purse. So far, so good. Now, what I've done is I've actually paired numbers up. I've paired numbers like, let's say, I paired the first second with 4. I paired the second with 8. So this was my seconds, and this is the feet. So there's a pairing going on. One value pairs up with another value. Okay? Look at the first word on your notes. It's called relation. I'm going to write this down. I'm going to copy that down. A pairing of input values with output values. Write that down. A pairing of input values with output values. The
write that whole thing.
Yes. So that's the first word, relation, huh? A pairing of input values with output values. So go ahead and, next to that, go ahead and just draw a very small horizontal and vertical axis like this. A real small one. Yes.
Part of the equation is it a equals 4x plus 1?
Oh, you're asking for, so you're,
Is that the equation for the thing? For the other thing?
oh, for the thug, we're gonna get back, so hold that, put that in the back burner right now, okay? Put in the slow flame, okay, slow burn, come right back. So input, go ahead and point at the horizontal axis and go to put inputs. And here, point at the vertical axis and put outputs. The numbers that are on the horizontal axis are always your input values. The numbers that are on your vertical axis are always your output values. You guys have graphed stuff before in prior math classes. So this is no, you're not a stranger to graphing. If you are, I'll give you some catch-up work and some tutorials on that. So just for your sake, every time we're graphing, the horizontal is always your input values, the vertical is always your output. We're moving right along. Now, coming back to the thug. Let's go back to the thug. Let's study his thuggery. Okay. So he's running away. At 3 seconds, how many feet is he away from the old lady? You sure? 12, 16. You said 12? We're going by 4, huh? Look at 4 feet for every second that passes. 4 feet. At 4 seconds, he's 16, and so on. Dot, 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 dot. Now, thugs for the most part are usually out of shape. Their diet is like drugs and alcohol, marijuana, leftovers in their mom's refrigerator because they don't really have a job. That's what the typical thuggery. So he's going to end up stopping. He's going to stop running sooner or later. He's not going to run forever. What second he's going to stop running? Well, that depends on this guy. Check this out. We have a cop coming into the picture. Here's a cop. Now this is related to those who want a free assignment pass later. You don't have to solve this, but the cop, after a 4-second delay, so the thug grabs the cop the lady's purse, starts booking it. At, remember the speed was 4 feet per second. He's running. After a 4-second delay, the cop begins to chase the thug. At what time will the cop catch up with the thug if he's running at a speed of 5 feet per second? Now, 5 feet per second is a little faster. Now, before we solve that, notice, as the thug runs away, let me connect these points here. I can connect them, by the way, because the thug is running away even at a half a second. At a half a second, the thug is about 2 feet away. At 1 full second, the thug is 4 feet away. At 1.5 seconds, the thug is 6 feet away. So even half seconds count here. Because he's still running even in between seconds. So I'm going to go and connect these points with a line because the line represents that these are different distances the thug is away from the old lady. Now, is there ever a second where the thug is 2 distances away from the old lady? 2 distances? Or does every second have exactly 1 distance away from the old lady? In other words, at 1 second, he's 4 feet. At 2 seconds, he's 8 feet. Is there ever a situation where he's 2 different distances away from the old lady at the same second? Would that be possible? Let me do that again, watch. I'm gonna go by twos. So at 1 second, the thug is 4 feet. At 2 seconds, he's 8 feet. 3 seconds, that's 1, 2, 3 seconds, he's 12 feet. Is there ever a point when the thug is 2 different feet away from the old lady at a specific second? So look at 1 second, he's 4 feet. At 2 seconds, he's 8. Well, at half a second, he's 1 foot on. Look at 0.5, he's 1 foot away, actually 2 feet. Is there ever a time when he's 2 different distances away from the old lady? Can he be 2 feet away from the old lady at the same time as 4 feet away at the same time? He cannot, because he's constantly moving. So, watch this now. He always has to be a different amount of feet away from the old lady at every given second. So we call that a function. Watch this. I'm going to write that down. A relation that pairs every input with exactly 1 output. Write that down. A relation that pairs every input with exactly 1 output.
That's supposed to be output, right?
Say again?
That's supposed to be output, right?
There we go again. My coffee didn't kick in, notice. Output. In other words, watch this. Let me go back to my thug graph. What if I had this? What if at the, let's see, that was 3. How about the 4th second? Let's say at the 4th second, the thug is 16 feet and 18 feet away. Look at this. Look at this right here. This is 4:16, and right here, this is 4:18. This doesn't make sense because a thug here at 4 seconds is 16 feet away from the lady, and at the 4th second, the thug is 18 feet away from the lady. That makes no sense. A person can't be 2 different distances from the same point, from the same lady. So notice how there's 2 different outputs for the same input of 4. This is my input, and I have 2 different outputs. That can't happen. Look at the definition of function. A relation that pairs every input with exactly 1 output. There can only be 1 output for every input in order for a relation to be a function. Let's go on to the next word. It'll start becoming clear, watch. Domain. Domain. The domain is the set of all possible input values for a function. The set of all possible input values for a function. So for the thug, the inputs were the seconds or the feet? What was the inputs for the thug?
4 feet per second.
That was a rate, but what were the input values for the thug? Seconds or feet? feet. Okay, so let's see. Remember,
He was the output.
so the set of all possible inputs of the horizontal axis, this represented seconds, this represented feet. So for the thug, the set of all possible input values was all the seconds. Okay, it's right here. This is all the seconds for the thug. So all these input values, 1, 2, 3, 4, the thug kept running a certain amount of feet. All these values are what we call the domain. Where does the domain stop for the thug? Well, we're going to figure out later. When the cop catches him, he'll stop running. Right? Garcia, stay with me. Medina, stay with me. 16 seconds. The cop will catch the thug at 16 seconds? You're positive?
Yeah.
Okay, if you got that, you're going to get the free assignment pass. So let's keep going. Hello, Mr. Minute. Sure. No, Mr. Minute. Okay, so, yes, hit it.
Would it be 60 seconds for the dog or for the cop?
For the cop to catch up to us, they have to reach the same place. For these 4 seconds, well, I just,
Do they have to be in the exact foot? Or can the cop be one ahead of
because I put like a,
Well, to catch the thug, that means they'll have to have ran the same amount of distance, huh?
Yeah, but since he's ahead by 4 seconds,
yeah, so
they
when
would end up catching up to him, but they're never going to be at the exact same spot.
he's gonna be, once he's run for 16 seconds and
Okay, wait.
So that-
Ionovich, hold that thought. So look at it. Let's say you get a 5-second head start from me, and I catch you, and I'm running fast. If I run faster than you in terms of speed, I'll end up catching you eventually. There'll be a point in time. So you're running, and I'm running right behind you in red. When I catch you, let's say I catch you right here at this point. When I catch you, I'll have ran the same amount of distance you have. I'm just going to get to this point quicker than you are. But there's a point in time where I'm going to catch you, and we'll have ran the same distance. Look, there's your distance.
same distance but different time.
Same distance but different time because I'm running quicker. So it's going to take me a shorter amount of time to get to that distance. So that's kind of what's going on with the cop and the thug. But before we get there, let's go back over here. But I'll let you chime in. You're calculating something? You said 16 seconds?
No, I said when the thug reaches 20, the cop reaches
20
after
what?
the thugs run at 20 seconds and he reaches about 80 feet.
Uh-huh.
So it'll take 16 seconds for the cop to reach 80 feet.
So it'll take the cop 16 seconds to catch the thug.
Yeah.
Okay, we're going to test that right now. Hold on. Oh, don't worry about it. Okay. It's worth a free assignment patch. You're not going to have you're not going to have a question like that on this Friday's test. Don't stress out. That is a higher level question. Well, let's come back over here real quick. So all the input values would be all the values that are on the horizontal axis for the thug. In this case, it was the seconds. That's what we call the domain. The domain is always the x value or the values that have to do with the horizontal axis. Question so far? Moving right along.
I mean,
Range. Go and write this down.
the way I tested it to see if it was right, I just multiplied 20 times 4 and I got 80, and then I multiplied 16 times 5 and got 80.
Got it. Give me a second. The set of all possible output values for a function. So now we're talking about all the values for the vertical axis. Write this down. Yes, sir. Say again? Yeah, almost. You write this down, right? Sure. We'll write this down. Okay. So the range for the thug would be all the feet values, all the values that are in feet, from 0 feet to whenever the cop catches him. I don't know when his feet will stop. He'll stop running. So the range will be from 0 to whatever the amount of feet he stops running. Mr. Jovanovic says he'll start running at 80 feet. So in that case, the range would be from 0 to 80, just the feet. The domain would be 0 to whenever the second stop. Okay? Independent variable, the input values of a function is the independent variable, the input values. And the dependent variable is the output values of the function. All right. Moving right along, moving right along. Want to flip the page? Say again? Not yet. We're going to come back to that. Want to flip the page? Actually, you know what? You're right. My bad. Down here on notes. For notes, let's go ahead and write identify the domain and range. Identify domain and range. The domain and range. And determine whether the relation is a function. So identify the domain and range and determine whether a relation is a function. Yes. No. You're off, Mr. Guido. See you later. Identify the domain and range and determine whether a relation is a function. We're going to do two examples. 3, 2, 4, 7, 5, 8, 3, -7. So identify the domain and range and determine whether the relation is a function. I'm going to put D for domain. The domain here is a set of all the input values. What are the input values here of this relation? The inputs would always be the horizontal axis, which is always the first numbers. So 3, 4, 5, and I'm not going to repeat 3 again because we already put 3. So there's my domain. It's just all the input values. Look, it's the first number separated by the commas. The first numbers of the ordered pairs are always your input values. How about the range? The range are always your output values. 2, 7, 8, and -7. You with me? Sit on. If you need paper, I got paper. I don't need a Gatorade bottle there. All right, that's the first mission. We identified the domain and range. Now, is this a function though? Does this represent a function? It does represent a relation. There's a pairing of numbers. It's a relation, but not all relations are functions. We got to ensure that every input has exactly one output. Think of the definition. I underlined it here, and I'll circle it. A relation that pairs every input with exactly one output. Is that going on here? Let's see. It's not. Let's see. Give me an argument, Mr. Torres. Come on up. Give me an argument. I think he said no. He said no. Give me an argument. Torres is saying it's not a function. Give me an argument. Hit it. 7 and negative 7?
Yeah.
But they do have different inputs, so this input has exactly one output, input has this output. The question is, does every input have exactly one output?
No.
Which one does it? Okay, thank you. It's either a yes or no. We can lucky guess it, but I need an argument. Is this a yes or a no? Is this a function? Does every input have exactly one output?
Yeah.
Are you sure?
No.
Does 3 have exactly one output?
No, it doesn't.
It doesn't. It has negative 7 and 2. Look at it. The same input, 3, has 2 different outputs. So this would be not a function.
Look at behind you the chart.
I never understood the whole question, but I just.
Hold up, I'm not doing it. So notice the input of 3. It has this output of negative 7 and it has 2. There's 2 different outputs for the very same input. Therefore, it's not a function. If every input has exactly one output, then it's a function. But this is a case where one input doesn't have exactly one output. It has 2 different outputs. 3 has the output of 7, negative 7 and 2. I saw a hand over here. Important? Okay, got you. Last example. 2. So I'm going to represent the function now in the table. So notice I gave you the function, the relation as a table instead of this ordered pairs. All right, let's state our domain. I'll put it in green again. So the domain is just all the inputs, the x values, the horizontal axis. The domain here would be negative 8, negative 4.5, negative 2, and 8. Where I get them? Just an exercise. How about the range now?
Which ones did you come up with? Well, X and Y or just X?
So you
Well,
basically-
here's your x's, here's your y's.
So you just dot all the numbers.
Right, which came up. But I'm thinking of a type of example for discussion. Watch. Look at the range now. The range would be 3, 7, 4.5, and then 3. 3 repeats itself, so I'm not going to mention 3 twice. So the range is all the y values, the domain is all the x values. Now, are you with me? Phone's away right now. We're almost done. So I got my domain and range. Question now, is this a function? And then give me an argument.
Yes.
Argument.
Because every output has every input has output.
Every input has an output?
You don't have different.
So every input has an output is your argument? Well, that was the same over here. Every input has an output. But this wasn't a function. Right? Every input had an output. We can give you an argument. It's not a function. Give me an argument, Lozano. Okay. I like how you're thinking. Notice, I have the same output here, but the question is, watch this now. Does every input have exactly one output, is what you want to ask yourself. Does every input have exactly one output? Let's see. Does every input have exactly one output? Let's see. Does every input have exactly one output? So far, yeah. Every input has exactly one output. It just so happens that two different inputs have the same output, but every input has exactly one output. This would be a function because every input has exactly one output. The inputs are always your x's, the outputs are always your y's. Right? The inputs are always your horizontal axis, which is your x-axis. The outputs are always your y-axis.
What about your 4.5?
Okay? This is the output, huh? This input had exactly that output. Okay, this input had exactly that one output.
If there's two of the same ones on the input on the x, then it's not a function. But if it's on the
So
y,
let's look at example 1. Did every input have exactly one output? No. The input of 3 had two different outputs. It had 2, and it also had -7. So there was one input that didn't have exactly one output, therefore it's not a function. Here, even though you have the same output for two different inputs, it still satisfies the definition of a function. This would be yes, a function. We're going to put yes. A function. The key to this is the words exactly. If you're like Miss Medina who's saying she doesn't get it, you want to underline it, you want to highlight this what I just circled right here, exactly one output. Every input has to have exactly one output for it to be a function. If you have one input that has more than one output, it's not a function. It's got to have exactly one. Exactly means not more than one, just exactly one. Question? Okay. For the rest of the time, we have 45 minutes. Go on to assignment 4. We're going to continue.